Okay, your video for today is about transforming linear functions, 11-4. So take good notes, make sure you write everything down. Okay, the very first thing I want you to do is remind you, it should be a reminder about linear transformations. Okay, let me emphasize the fact that this should be a reminder. Okay, when we were going to do a horizontal shift of a function, we would add or subtract this value to the x value on the inside of the parentheses. When we were going to do a vertical shift of a linear function, we would add or subtract this value to outside of the parentheses. Notice how this k is on the outside and this h is on the inside. Those two represent vertical shifts and horizontal shifts. Okay, and then the next thing that we did was we talked about reflections across the x and the y axis. So if it was reflecting across the y axis, then we made the x value negative. Notice that we're making the x value negative. If it was reflecting across the x axis, then we make the y value negative, which meant that we applied the negative sign here on the outside of the parentheses. Okay, these here are some pictures. Those are pictures of what it looks like to reflect across the x and the y axis on those two problems. And then at the bottom here, we talked about a stretch and compressions. And first of all, we said that, for example, here that this would, if it was a horizontal stretch, that it applied to the x value. So we do 1 over b times x, and that is sort of new for that part. And then if it was a vertical stretch, then we multiplied on the outside to the y. Okay, so one of the main things that I want you to remember is that horizontal, for anything horizontal, then it applies to the x's, applies to the x values, and we'll say on the inside of the parentheses. Okay, and then obviously if it's a vertical shift of any kind or vertical transformation, then it applies to the y values. Excuse me. The y values on the outside of the parentheses. So these two big facts that I want you to remember: horizontal and vertical transformations. Okay, we're going to talk about some examples of those, and I hope you can just read these and follow along. This is saying let g of x be the indicated transformation of f of x. So this right here, f of x, is our original, and g of x is going to be the transformation. Okay, so this is saying that f of x, our original function, is 2x plus 3, and it wants us to do a vertical translation 4 units up. Okay, so I know that if I'm doing a vertical translation 4 units up, I'm going to add 4 on the end of f of x. Now it told me that f of x right here was the same thing as 2x plus 3, so I'm going to plug 2x plus 3 in right there, and I still have the plus 4 on the end. Okay, and then to get g of x, I'm just going to simplify that equation and make it 2x plus 7. Okay, 2x plus 7. So we get our new translation or transformation as 2x plus 7. Okay, and then so let's do the next one. The next one is this. It says that f of x for this problem is 3x plus 1. F of x is 3x plus 1. And we want to do a translation that is 2 units to the right. And I know that if it's to the right, that's a horizontal shift right. And if you remember with me that a horizontal shift right meant this. Say that f of x is the original, then we would do g of x, and if it was to the right, we would use minus 4, okay? Minus, because it's the opposite. Remember, it's going to go opposite. So what I'm going to do for this function is I'm going to write this. I'm going to write g of x is equal to 3, and where there was an x, it was an x, but now it's going to be x minus 4, and then plus 1 will be on the end. Notice that for this x right here, I'm going to substitute x minus 4. And then I'm going to work this out. This would be 3x minus 12 plus 1, and then continue to work that out, 3x minus 11. So I get g of x is equal to 3x minus 11 is my transformation, my horizontal shift right 4 units. Okay, my next example is going to be a, it says let g of x be a horizontal compression of f of x equal to 2x minus 1 by a factor of 1/3. Okay, write the rule for g of x and graph the function. So I'm doing a horizontal compression. So if you remember from 2 slides back, that meant that it's going to be f of x is going to be equal to g of 1 over b times x, right? And so that's something that you have to remember, and that's new from when we did it earlier in the year. We said that it applies to the x, but now we're actually going to put 1 over b in that spot, okay? So what we're going to write here is this. We're going to write f of x is 2x minus 1, okay? But now this is going to change. This whole thing is going to change to g of x, okay? G of x is equal to 2, and in with the parentheses, since it's a horizontal, it's going to be inside the parentheses, okay? Inside parentheses, okay, with the x, and it's going to be 1 over 1/3 x minus 1 on the end, okay? And so I'm going to erase this and show you the what it's going to look like in the end, okay? So it's coming up, and you can see that it's a horizontal compression, compressing f of x by a factor of 1/3, and this is what we just wrote down, okay? This is what we wrote down right there earlier, okay? And this right here will turn into 3x, okay, which will be 6x minus 1. So our new function, or our new transformation, will be 6x minus 1, okay? Our new transformation is 6x minus 1. And then let's let our next one be, this says let g of x be a vertical compression of f of x is 3x plus 2 by a factor of 1/4. Okay, write the rule for g of x. Okay, so for this problem, I'm going to start off by writing g of x is equal to 3x plus 2, and I know that when I do a vertical compression that's going to be outside the parentheses. So I'm going to multiply the whole thing by 1/4. Okay, the whole entire problem by 1/4. So this will be g of x is equal to 3/4 x plus, and that will end up being 2 over 4, which is 1/2. Okay, so my new function will be g of x is equal to 3/4 x plus 1/2 for the new transformation. Okay, so that would be the rule for g of x. So that's your video notes for today. It can be confusing. We'll go over it more in class tomorrow.